All right, let's get started. We have our very last lecture for the course, lecture number 10. And lecture number 10 is a hodgepodge. It has a bunch of stuff in it. And I'm going to wait and do the final exam review second. Because here's what happens. Everybody walks in halfway in the middle. And everyone's going to miss the beginning of the final exam review. So I'm going to do that second, and before I do that, this is really short. This is about 20 slides or something, and I'm just going to hit on some important topics that we didn't really cover yet. So you probably want to download and read Lecture 10. It's not bad reading. That's this one right here. And just so you know, and just in case I forget to tell you, there's only 11 lectures in the course, and all 11 of them are on the final exam. So I wrote the final exam this weekend, and I forgot to pull it out, but I actually have it with me, and so I'll be going over it at the when I get done with this. But I was careful to pull out of everything, so nothing was left out, which is pretty good. So, all right, so let's get started with this one, and then I'll talk all about the final exam when we're done with Lecture 10. A couple announcements before I get started. We're still sending out the ITU CARES, Japanese Relief, Volunteer Relief. I don't know what this is. What is this?
Help Japan.
Help Japan. Relief. Is there do we have any Tupperware today?
Yeah, it's at the entrance.
D for healing? Dealing for healing. Is it located in Las Vegas, or is it here in Sunnyvale? Dealing for healing?
The Tupperware is at the entrance of the classroom.
Oh, at the entrance of the classroom we have... Oh, I see the Tupperware. The Tupperware is in the back. It's on a chair. And please put your hard-earned dollars in there. But save a little bit for coffee so that you're able to take the exam. And you're awake enough to take the exam when that happens. So. All right, so documentation, garbage collected, nested classes, and interfaces. I actually kind of showed you a little bit with one of my examples, the nested classes. But I just want to kind of just give you a brief overview of these concepts. So you have some kind of a clue. It would be disastrous to leave this class without actually even talking about any of these three topics. In terms of the documentation, there's actual libraries that are included Java Doc. So the JDK actually contains a tool named Java Doc that generates HTML documentation. When you go online and you look up all the packages and stuff, it's all in Java Docs. And personally, and I probably shouldn't say this while I'm recording it, I don't like the format. It doesn't lend itself well. It's a hierarchical kind of structure with HTML, so you can click on the links and stuff and expand things out and close things, but it always seems a bit too brief for me. So, but you might like it, and it's all over the place, and this is where it's coming from. The documentation is actually inside of the packages that you're including, and inside of everything we have comments, and you'll see it if you start looking through those files, but nobody ever does that. Instead, you can generate the documentation automatically and create it into an interface that you can put on the web, and you can provide help, actually, which is what Java does. I mean, in terms of the base classes and things. You can do the same thing for your programs when you're writing your applications. And this is basically kind of an overview of how it works. It's generated from the documentation comments that you're putting into the code. And it doesn't take any extra effort, actually, which is really nice. And you can get programs like Eclipse as a web browser, as a interface, IDE interface, to automatically create Java Docs for you. And you can actually view and go through the Java Docs and see where you've missed things as well. So it depends on the IDE you're working with, what the goal is of the project, and the level of documentation you're doing. But the theory is you're putting comments just the same way as you'd normally put comments in the source code with the commenting style. Gets read as comments, but then we can generate documentation from it automatically. A Java Doc utility extracts information from the following items. It's basically everything. It uses the public classes, the interfaces, public and protected methods as well, fields or data members, and packages. So everything is actually kind of included, with a few rare exceptions, and you'll never run into that problem, actually, of it not being included. So what you're looking at in terms of the doc comments, and here's an example. The doc comments are starred with 3 stars, and 2 stars here. Well, 3 characters. The / 2 stars, and continues on to the next one. You could have actually put as many stars as you want in there. In fact, people get carried away with that sometimes. You know, they got stars and all the ASCII notation and make it really stand out. But the interesting thing is you don't have to read the code. If you do it correctly, do it in this kind of fashion, and what ends up happening is that it will automatically generate at a click of a button, so you don't have to go back through and read anything. You may also use those you're familiar with already, the double backsplashes, the double slashes, 2 of this character rather than the asterisks. If you do that, it doesn't actually get generated. It will be comments that you put in the code that don't go into the Java docs. So you'll see sometimes people will use a combination of both, because maybe they just want to internally put a little note there to, note to self, take this out in the next reversion or something. But maybe you don't want that note to show up in your Java documentation. So you have both styles of legal commenting that you can put in there. This one's going to generate the information for you. So the leading asterisk characters, the preceding white spaces are ignored, obviously. And the first sentence of the comment is the summary of the identifier. And so you can use most of the HTML tags in the text format, providing cross-references to other documentation. So you can actually embed HTML in here because it's going to be implemented. It's just raw text, so the raw text of your source code file. And if you embed HTML in there, you can actually put like links in there to your website, links in there to third-party tools and stuff. So you can actually kind of make it pretty feature-rich. So only doc comments that immediately precede the class, interface method, or fields are processed. So not everything is, just the ones that immediately precede the class and the interface. In terms of what this example is looking at, this would be immediately preceding the declaration, of this particular method here. So, all right, and then I said before, you can download and you can read through this on your own and actually kind of at a slower pace, I would say. And you weren't required to do this for any of the programming assignments that you had for the course either. You can also put tags in the doc comments. Tags are kind of like those links that take you to different spots in the document when this is created. So it creates a cross-reference link to other Java docs and documentation. So it's used to see also section at the end of the documentation that's put in automatically. So the see also will be your tag list. And your tags are qualified, so you qualify the identifier sufficiently, and how you're doing is you're specifying the class interface members by using this pound key before the member name, and this is an example of it down here. If the method is overloaded, list its parameters, specify the class interface with simple names, and if it's from another package, specify the other package name. So in terms of the example, you can say like, C get name, and then where it's coming from and all of the different locations in terms of the package that's it's located at. You can also use a label after the entry reference, and the label will be actual text that's going to be displayed in the references at the bottom of the Java doc. So that you don't really see too many people using unless you have to for a company, and then what ends up happening, you have to follow their standard. So it's whatever your boss wants you to do, essentially, is what you're going to do for that. But knowing that you can do this is an important concept. The style that you're doing it in is going to vary depending upon where you're working. So when we see this at link, this is similar to the at C in terms of the links at the bottom, where we create the cross links. This particular one, but it embeds the cross link in the text of your comment. So sometimes you actually kind of read code and you see this stuff in there, and that's what it's all about in terms of being able to specify the tags, and put in meaningful identifiers. And here's an example here. Changes the value of the return by call to, and then this is going to reference that. It's going to provide a link to reference it in terms of get value. And then the at parameter documents a single parameter of a method. So you'll see, you'll see it used with the parameter tags, one for each of the parameters of the method, and the syntax looks like that. You know, actually, sometimes when you get source code documenters, in fact, Eclipse, I believe used to have a feature, I'm not sure if it has it anymore, that would do it for you automatically, actually. You know, you'd go through and it would create kind of a template for you for each one of the parameters that you were, it picked up in terms of a template. And then you could fill in the comments on your own. So sometimes you'll see it embedded in tool sets. So the at to return, you know, documents the return value of the method. So you can really get carried away. You can document everything, the method, the parameters of the method, the return value of the method, the throws, the exceptions. And this is where I say I'm not going to go through and go through each one of these items. It's great reading, and you can use it as a reference, actually, to kind of figure out what would be the name of the tag if I wanted to reference the I/O exception that was going to occur in this particular method or something that I was documenting. Then you can even, you know, document depreciation, author, version, you know, since, you know, when the entry was added to your system, like a date or something of that nature. And as an example, the graphics.java, if you look at Java docs graphics.java, if you run that command, Java docs actually creates the HTML document for you. So just like when you run Java C and you create the intermediate code, the binary code that you're running, Java doc is the command that you would actually use right here on the bottom to actually compile the Java docs. It's not going to do any of the compilation of the code. It's just going to create your HTML document out of that. And then you can take that and upload it somewhere or make it available on your particular internet. So package documentation, unlike the doc comments for the package themselves, they're not defined in the source code files. What we've been looking at is putting these comments, these tags, in the actual source code that we're writing. So in order to generate the package comments, you need to add package.html in the package directory, and that's going to provide your documentation for you for the package. That you actually kind of see a lot in terms of a standard. Sometimes they're even empty. They just put that file in there just in case, you know, you're going to want to edit something. So the contents of the package.html between the body and the middle of it will be read as if it were Java doc comment. So you're kind of creating it. It's not really manual. It's still an automatic process. You don't, even though you're creating the file yourself. Depreciated author version are not used in this particular case because they're not related to the document. They're related to the package. We're talking about the package documentation at this point. So the first sentence of the body is the summary of the package. Any of the C's of the links must be fully qualified. So you need to know what class, even classes and interfaces from within the package itself, so you can know where they belong to. Because if you're thinking about the package level, we're thinking about the directory, the hierarchy. Which might be nice because you might not know, you know, maybe you have different versions of the same package and there are different locations and you're using, one's a test, the other one's a beta or something, and you're switching back and forth. It's nice to be able to document which one is which. It kind of self-documents it. Okay. Let's talk about garbage collection. Okay, so if y'all did the midterm, and by the way, the midterm is due this coming weekend. It is due April 17th. And it needs to be uploaded into the ITU EMS in the midterm exam entry. Yes. So if you did that, I think I even asked you something about whether or not there was a delete in Java. There's no delete in Java. So C++, when we work with dynamic memory allocation, we have a new and we have a delete. In Java, we have new all over the place. Everything's new. Create this new, create that new. And we have the JVM, the Java Virtual Machine, that does our garbage collection. And I've been talking about it for the last, I don't know, the entire term. I've been saying the word garbage collection, but I never really actually defined what it was. And what this does is it keeps the Java Virtual Machine, in terms of its garbage collection, actually keeps a table of all of the referenced objects. And it'll go through the table and see if the object is there. And then it'll go through its memory and see if there's a corresponding link in the table. If it does, it's a current object, which means you've said, you know, create me a new employee, and you know, you're using it and you have a reference to it in a running program that's in memory, is actually using it and referencing it, kind of like pointers, actually. It's a pointer table. When it comes out of scope, when it's no longer being used, I don't know exactly how long it takes because it depends upon the Java virtual machine, the internal architecture, and the implementation of this concept. But theoretically, the memory will actually be removed, the item that's sitting in memory will actually be removed, and then the memory becomes available for the next program that needs, the next object or piece of information that needs to be stored. Because in working with dynamic memory, and this is definitely a dynamic memory allocation kind of concept, the same thing happens with operating systems, with other programming languages that we use. But normally the programmer is responsible for removing something that they're putting into memory, and that's where that delete comes into play. So objects that are created using new, but there's no corresponding delete operation to reclaim the memory, and we don't need one because we have the JVM doing it. So, in fact, when they first started introducing Java, that was one of the huge selling points. It was like, oh, this is a more reliable language because it does its own garbage collection and its own memory management. And unless you were working with pointers in C++, you probably really never even experienced a problem with it. But if you were, and if you have some higher level sophisticated type of programming kind of design, you're utilizing dynamic memory and you're creating dynamic arrays and you're doing all this stuff manually. So you actually have to pay attention. And garbage in the future, in the past garbage was a problem. In the future, we don't even think about garbage anymore. In fact, it's kind of, I can wait until the very last lecture of the course to mention garbage collection because it has nothing to do with you as a programmer. It's totally built in as a feature. If this were a C++ course, you'd hear about this in like week 1 or 2, probably, because you'd have to do it yourself. So the JVM uses garbage collection to ensure that any of the referenced objects will remain in memory, and then frees up the memory and deallocates objects that are no longer reachable for references and executing code. Usually there's 1 or 2 people that wonder, why do we have to worry about that anyway? Because eventually we're going to run out of memory. If we keep loading stuff up, loading stuff up, loading stuff up, we only have a limited resource, actually. So the memory management and the way that the memory is being organized and the way that it's being used leads to efficiency, hopefully. Leads to fast-running programs that have resources available. So the garbage is collected without your intervention, but collecting garbage still takes time. And it still actually happens, so your running program, depending upon your environment and how much memory you have available, the execution speed might vary depending upon how often the garbage collection is taking place and what kind of scheme, what kind of algorithms actually put in. If you take an operating systems course, you learn about garbage collection algorithms. There's several different varieties on the market, and everyone has their own perspective, viewpoint on when should garbage be collected. Because what you don't want to do is throw something away that you want. So that could cause an unstable and reliable environment. So the collection is not guaranteed that the memory will always be available for new objects, so it solves a problem. But not all the memory allocated problems. It doesn't solve everything. So, and believe it or not, that's one slide. There's your entire, that's why you study Java instead of C++. So, and I think they're actually going to be offering C++ in the summer term. For those of you who I've been talking about C++ and Java, don't be afraid. It's not that bad of a language. But when you compare it with Java, it's harder. But it's not that bad of a language. So, and there are still a lot of need for C++ programmers, so don't be afraid to take that class if it's offered this summer. All right, nested classes and interfaces. So this is another thing on day number 1 I told you when I showed you Hello World. I said all the classes go in their own files. And I said, you name it with the name of the class, and it's .java, and when you created it, if you put it all in one file, what's going to happen is it's going to put it out into 12 different files, depending upon which classes you created. And that's good for most applications. However, and we saw this actually in the graphics program that we put together for the last assignment, you probably had to nest a class inside of a class. You do that for scope purposes, and because the 2 classes are sharing data. So it's nothing more, you already know how to nest classes and interfaces. You already know this concept, actually, because all you do is put one inside of the other, essentially, is what you're doing. You're doing that so that you can raise the scope level. Otherwise, a class only knows about what's inside of a class. And we have to work with the public interfaces between the classes. We don't have like this global variable that we create in like a C++ environment when we go to define. Or we have all this stuff and then the whole program shares it. No, instead we have class, 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 class. So in order to create the facilitation of the communication between, we nest. And so one of them automatically has access to everything about the other one because it's inside of it. It basically is owned by it. So classes and interfaces, and we all hopefully know what an interface is by now. I'm sorry, did you have something?
Can I ask?
Yes?
So how can you differentiate between the garbage collector and malloc or like in C++?
How can we differentiate? I had a question on garbage collection. How can we differentiate between what?
Garbage collector in Java and malloc malloc in C++.
Well, malloc is different because that's the manual way. In fact, a programmer would call malloc and free, to free up things, and you would be using things in terms of the memory management from a programmer's perspective. And you can differentiate that from Java real easily because there's absolutely nothing a Java programmer can do.
So in hidden aspect is Java script as your syntax property is malloc malloc in C++. That's it.
Oh, for malloc? It's the C version of new and delete.
We need to write in syntax in the C++.
Yeah.
But whereas in Java,
there's no way of writing anything. Yeah.
Hidden thing, right?
It's already part of your environment. It's no longer a programming consideration. You would never call malloc. You would never use a delete. You would never release anything on your own. In fact, you don't have to worry about where anything is, and you can't work with pointers either.
I have given the last class example like pack method. So where exactly do the garbage collector, like pack method? In the last class we have used
Pack organizes everything. It doesn't necessarily do garbage collection. Pack doesn't do garbage collection. In fact, inside of Java, if you want to take this a step further past garbage collection, we also have defragmentation. It will actually has its own memory defragger that's built in as well.
So that means pack method, can you organize at the time of runtime?
Can you automate it?
Organize it sequentially? Like
in Java or C++?
in Java.
Yeah, you just run pack and it's going to assemble the units for you and make sure everything's refreshed properly. It's more of a, how's it going to show on the screen? How is it going to display? And is it going to, otherwise, what ends up happening is you get things like flickering. You get things like something's underneath something else. It doesn't show, the whole entire program is not going to load simultaneously. When you pack it, it delays, so it loads simultaneously.
Because the output is coming up depending upon the compile, how the one by one sequentially, right?
Yeah.
So the pack, how it can help to us. So sequentially.
It refreshes for you so that everything loads smoothly. You can leave it out, the program will work just fine, 9 times out of 10. Other times you might see flickering, you might see something delayed. It might not, the synchronization of how the screen's going to paint might not necessarily be optimal in a GUI application. You only use pack for GUI. It has something to do with, and it's an internal method. In fact, I don't do very much graphic development, especially with Swing or more AWT, but I would say go online and look it up. You'll see why people use it. It's like one of those things that for beautiful interfaces. I don't know. I'm more of a command line kind of person myself. And I don't really actually, for some strange reason, I know I probably shouldn't say this on tape as well, but I'm not a fan of GUI development in Java. I would prefer to do it in C++ actually, with the resource creator and the whole. It's just that the tools are a lot better. It just seems so, even when you use those third-party tools and you do graphics stuff in Java, it always seems like the files are huge, the thing takes forever to load, and it looks like Java, It doesn't give me that Microsoft look and feel, Although I hate Microsoft, I like programming. I think is a little easier, So. Alright, so classes and interfaces can be declared inside other classes and interfaces, either as members or within blocks of code. So that's what it means by nesting, or declaring a class inside of a class or an interface inside of an interface, for which a nested class or interface which is declared as static acts like any non-static class or interface except the name and the accessibility are defined by its enclosing type. So we are still working with a static even though we're non-static inside of a static class, if we're doing that, or a static interface. Static nested classes are members of the enclosing type. So just think the blanket, if you're going to nest it one class inside of another, you're still working with the outside class type. If that's static, everything inside of it ends up by default sort of falling within the same placeholder or the same type. So let's see what we got here. So we can access all the members of the enclosing type, including the private ones. Yeah, because we're nested. So you have private data members in a class, you put another class inside of the class, and now because we're working with it, and we're only nesting this class or this interface because we need to work with it. We're going to either override it or we're going to further implement, like in terms of the action of a GUI event, which is why those action classes were in there. We're going to implement some of the functionality that's going to occur when the outer class event is received. It sends it to the inner class and the action is dealt with. That's how we saw it actually last week in terms of the GUI program. So all of the scope is within inside of the nested class. So the outer class scope is the inner class scope, is what I'm saying. So inside the class, the static nested class interfaces can have private packages, protected or public access, while inside an interface, all of the static method classes are implicitly public because of the interface kind of concept. And they serve as a structuring or scoping mechanism for logically related types. So just think about scoping, and that's the reason why you're nesting interfaces and classes, because you want to create more of a general global scope for the class. I'm going to do I need to go over inner classes? I'll let you read through this. There's actually nothing on the final exam in terms of this concept. And I see most of you have arrived so far, and I know that's what you're here for. So, and I know that you're patiently waiting for me to get to that point. And actually, there's more people at the door, so let's see. We'll give it a few. I'll stall for a few more minutes. This is Lecture 10. If you have an interest in taking a more advanced course, and if you do a lot more GUI programming, you're going to find more of a need to nest. It's one of those things you do for the for special purposes, but you don't always do it. In fact, that's why on day one I told you, class over here, class over here, class over here. Because once you start nesting, then you start looking like a C++ programmer. Because you got inside the class, you got another class, and you got another class, and it's all in one file. It's all inside of one class, which is not necessarily what you want to do in terms of the design. All right, so there's only about maybe 4 or 5 slides here on it from nested interfaces, inner class kind of issues, outer class kind of issues. Inheritance, scoping, and hiding. All members declared within the enclosing class are said to be in the scope inside of the inner class. The inner class has its own fields and methods, can hide those of the enclosing object themselves. So you've got some, two different possibilities to kind of go through and look at if you want. Anonymous inner classes, if you wanted to, it's just going to be like a lightweight class that's going to be supported or it's going to do something. You don't actually have to give it a name because you're never going to call it. It's inside of another class and it's nested. You can actually make them anonymous. So you declare anonymous classes that extend the class or implement an interface. So this type of class is defined at the same time that you instantiated with new. So here we got return new iterator, which is essentially we've got static iterator walkthrough. So where essentially anonymous classes can't explicitly extend or implement classes because if it does, then it's going to be a self-running class on its own. So in terms of the inner class, it makes more sense when you're not, when it's a small kind of implementation. Type is specified to new is the super type of the anonymous class. In terms of the type, anonymous classes can't have explicit constructors declared, obviously, because you can't really call the class outside of the outer class. So, constructors don't really make any sense in that context anyway. So, nested inside interfaces. putting an interface into an interface. The reason for nesting classes and interfaces inside of an interface is when you want to strongly relate to the interface inside of that interface. When some functionality is dependent upon that outer interface, you're overriding the functionality, you're complementing it, you're doing something to it. So you're defining a partial or complete default implementation for the interface. So. All right. You guys were, oops, what is this? Very patient. No, I don't know what that message was. I'm going to stop this video and start the other one because I'm going to post this next video out for the weekend, people. And this is your opportunity. So in my transition here, think about for a few minutes. Your opportunity to ask questions about what will be on the final exam. But I'm going to give you a rundown first. But let me stop this.